Hi everyone, it's my pleasure to illustrate you guys our experiment. First, let me introduce my group member. This is Zekai Wang, who will help me with the experiment. And also, this is Enggen Zhai, who will do the recording part. And also, my name is Xinhui Qiangxu. Our purpose of our experiment is to find the connection between the angle and the mass static friction. In addition, there are some assumptions to make the experiment easier. First, is the force that acts on the bottle will be parallel to the surface. Also, the mass of the cover will be negligible. Lastly, we assume the pulley would be rotated freely, which means there's no friction on it. Our experiment will be done in 3 angle condition, and each of them will be repeated 3 times. Next, I'd like to talk about some equipment that will be used in the experiment. Basically, there is one large water bottle with a volume 1.55 liter, one small water bottle with a volume 550 milliliter, a mouse mat, a pulley, a beaker, a rope, a level, and also an angle judgeable table. The small water bottle is moving very fast.
We are going to reduce the weight of the water bottle until you can see that the water bottle is moving very slowly. Now you can see that the small water bottle is not moving. Then we are going to move to a level table and mark the level of the water remaining in the large bottom.
Now the table angle is 0, and we can see the small bottle is moving very fast, which means the drag force is much larger than the maximum static friction. Now we reduce the weight as the same process we said before. We can see the small water bottle move very slowly, which means the drag force is a little bigger than the maximum static friction. The small water bottle is no longer move, which means the drag force is equal to the maximum static friction.
The small water bottle is moving very fast. The small water bottle is moving very slowly. The small water bottle is not moving.
Then we mark the water level remaining in the water bottle at minus 22 degrees. Now I can see that the water remaining in the bottle is about 450 milliliters.
In order to reduce the data error, we did the experiment 3 times for each angle and got the mean of pulling force in each condition. Then we inserted the data into the static friction formula, which shows when the angle is 0, the friction force is maximum. And when the angle is equal, no matter the pulling force is upward or downward, the friction force is approximately equal. According to the formula, we learned the relationship between the angle change and the maximum static friction. Smaller angle, greater friction force. And when the angles are equal in a stable state, the friction force remains the same.